Hello all. In this video, we are going to solve a problem based on Gauss Seidal method. The required system data for a load flow solution, they were given in table 1 and 2. Okay, so and then we need to find the voltages at the end of first iteration, and we were given the acceleration factor as 1.6. So here we go with table 1 and table 2. So table 1, it was given with the connectivity between the buses, that was named as bus code, and the corresponding admittance, it was specified. Okay, so here this value is J8. Okay, so this is about table 1, and table 2 is about the bus code. Okay, so 1, 2, 3, 4, and the corresponding specifications. We all know very well that every bus need to be specified with four variables. They were real power, reactive power, like this, real power, reactive power, magnitude of voltage, and phase angle. But in load flow solution kind of problems, so any two of these four variables will be specified, and the rest of the two we need to find. Because those equations are non-linear, we will be adopting the iterative methods, and Gauss Seidel method is one of the iterative methods. So if we look at table 2, the first bus, it was specified with voltage and then corresponding phase angle, so it can be treated as a slack bus. Second, third and fourth buses, for all the three buses, they were given with the P and Q values, you can observe. It was not specified with voltage and phase angle. That is the reason why we count the remaining three, that as 2, 3, 4 buses as load buses or PQ buses. According to the given data, we can draw the bus diagram or line diagram of your given system. Okay, so here we go with first bus. Okay, so this is the second bus, third, and then fourth. And now the connectivity should be based on table 1 data. So from this table 1, so 1 to 2 connection is there, and whose admittance is 2 minus J8. Similarly, 1 to 3 connection is there, whose admittance is 1 minus J4. Next, 2 to 3 connection is there. Okay, you need to draw like this. 2 to 3 connection is there, whose value is 0.666 minus J 2.664. And then 2 to 4 connection is there, whose value is 1 minus J4. Next, 3 to 4 connection is there, whose value is 2 minus J8. So this value will be considered as Y12 or Y21. This value is Y24 or Y42. Similarly, rest of the elements 1, 3, 3, 1. This one is 3, 2, also equal to Y23. This one is 3, 4 or Y43. So from this diagram, we can obtain the Y bus using inspection method. So here Y bus is of the size 4 by 4 because we have 4 buses. The matrix will be looking like this: 1, 2, 1, 3, 1, 4. Similarly, the remaining elements: 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3, 2, 1, 2, 2, 2, 3, 2, 4 here. Here is 3, 4. Similarly, Y4, 1, 4, 2, 4, 3, 4, 4. So this has to be our Y bus. So here we need to calculate the elements of Y bus. We can categorize it into two parts, this matrix: diagonal and off diagonal elements. Let us go with the diagonal elements first. Okay, so Y11, just add all the line admittances which were incident at bus 1. So here very clear that it is Y12 plus Y13. So this is 2 minus J8 plus 1 minus J4. So if we do the calculations, we will be getting 3 minus J12. So like that, we can calculate rest of the diagonal elements. For Y22, it has to be Y21 plus Y23 plus Y24. Okay. Similarly, Y33 will be Y31, Y32 plus Y34. Next, Y44 can be Y43 plus Y42. All the admittances were given to you already, so you can do the calculations. In this way, we can find the diagonal elements. So all the off diagonal elements, which is simply like this. Y12 will be Y minus Y12. Okay, so which can also be treated as Y21. So in the similar line, you can calculate the rest of the values for off diagonal elements of your Y bus. So I have done the calculations already, and I will be writing the values. Y bus is equal to 3 minus J12 and then minus 2 plus J8 minus 1 plus J4 and then 0, because there is no connectivity between bus 1 and 4. So the elements can be repeated like this in a vertical fashion: minus 1 plus J4, 0. So here it will be 3.666. It's not plus, it is minus J 14.664. Here is minus 0.666 plus J 2.664 and then minus 1 plus J4. Okay, we can complete like this: 666 plus J 2.664 minus 1 plus J4. So next element will be Y33. This is 3.666 minus J 14.664 minus 2 plus J8 minus 2 plus J8, and here we will be getting the Y44 element, that is 3 minus J12. In this way, we can complete the Y bus using inspection method. Now we will be starting the Gauss Seidal method by assuming the load voltages. Okay, so here from table 2, it is very clear that bus 1 is a slack bus. So bus 1 at 0th iteration or the first iteration or any number of iteration, it will be the same value. Okay, so it is 1.06 at an angle 0. Okay, so now second bus voltage, because second bus is a load bus, we can assume a flat start, that is 1 plus J0, and on the similar way the bus 3 voltage will be also the same value, and also fourth bus. So with these initial guess voltages, we will be starting the Gauss Seidal solution using Gauss Seidal method. Okay, so we all know the voltage at kth bus at r plus 1th iteration as 1 by Ykk into Pk minus Jqk by Vkr conjugate minus sigma I is equal to 1 but is not equal to k to n Yki Vi r plus 1. Okay, so now the first iteration means the R count will be 0. First iteration means every bus voltage need to be updated. So at that point we can conclude that the first iteration was completed. So when R equal to 0, under which K I'm counting it as 1. If K equal to 1, from this equation what I can write V1 prime. So there is no point of doing any kind of calculations here, because we all know that the bus 1 is a slack bus in this problem. So no matter what is the count of iteration, it will be the same value. Okay. Now k count need to be increased, that is k equal to 2. So in this equation, k can be treated as 2 and prime, which is equal to 1 by y22 p2 minus j q2 by v2 0 conjugate minus sigma I is equal to 1 but is not equal to k. K here is 2 to n means number of buses. We have 4 buses, so it is 4 y 2I vi prime. Okay, so now we just go to table 2 once. See, just hold on for a while. Okay, so here is the table 2. So in table 2, it is very clear that it is a load bus. Okay, so because it is a load bus, P and Q values will be given as minus. Okay, so and also if you look at the table, bus 3, bus 4, they were also load buses, and so P and Q values must be given with a negative sign. Okay, it will not be specified in the derivation, but while we do the problem, we have to follow like this. Okay, because it is a load bus, it is going to consume the power. In order to indicate that kind of meaning, we will be having a negative sign. Okay, so let us go back to the equation. Okay, so here 1 by y22. So P2 will be minus P2 and Q2 will be minus Q2 as well. So minus of minus plus JQ2 will be there. V2 0 conjugate minus, I was just expanding the series. Why? I'm counting the I from 1. So V1 updated. So no matter what is the iteration, it is going to be 1.06 at an angle 0 itself. Next plus I count should be 2 now, but at this condition I can't be equal to k. Unfortunately k is 2, so you cannot write this term. So you can proceed with the next value, that is y2 3 v3 prime. Actually you need to write the updated voltage for v3, but it was not updated at. Bus 3 voltage is not updated at. That is the reason why you keep the initial guess plus y24 v4 0. Okay, and this y22 will be obtained. Okay, so for the first calculation I will be writing the values. So this y22 is 3.666 minus j 14.664. Okay, this is y22 from your y bus. And from table 2 it is very clear that P2 value is 0.5. Now it will be minus 0.5. Next plus j 0.2 by V2 initial guess is 1 plus j0, but we are considering the conjugate, so it is 1 minus j0 minus y21. Again it will be obtained from y bus. Okay, so y21 is minus 2 plus j8. Okay, into V1 is 1.06 plus j0. Next 2 3, it is minus 0.666 plus j 2.664 into V3 initial guess, that is 1 plus j0 plus y24. Okay, y24 is minus 1 plus j4 into 1 plus j0. Okay, in this way we need to do the substitutions. This portion is this one, this portion is this one, and finally this is the one. Okay, so with simple calculations we will be getting the updated voltage for bus 2. So whose value is 1.0119 minus J 0.0290 per unit. But in our problem, we were given with the acceleration factor. So for that reason, we are having this calculation, that is V2 0 plus alpha into V2 prime minus V2 initial guess. Okay. So this one is 1 plus J 0, alpha is 1.6, and this one is 1.0119 minus J 0.0290 minus 1 minus J 0. Okay, if we do the calculations, we will be getting it as 1.0190 minus J 0.0464. If you want to convert this into polar also, you can convert. Okay, this value will be 1.0201 at an angle minus 2.61 degrees per unit. In this way, we can find the updated voltage for V2. Now, the K count should be 3. Okay, so using the same previous formula, okay, VK formula is there, no, VKR plus 1. With that formula, you will be getting the updated voltage for bus 3 like this. This is P3 minus JQ3 by V3 0 conjugate minus sigma I is equal to 1 but is not equal to K. That means not equal to 3 to 4 Y 3I Vi R plus 1. So here R plus 1 means only prime or 1. Okay. So here also you need to consider that we were given with a load bus. Bus 3 is a load bus. So P3 should be minus, Q3 minus of minus, plus will be there. Okay, so like we have done in a earlier calculation, in the same way you need to proceed. So Y31 V1 updated plus Y31 V2 updated value is available now. So you can avail that. That means this value plus, so I can't be 3. So next value will be 4. Why? 3, 4, V4, 0 only because bus 4 voltage is not updated yet. In this way, you can able to calculate V3 and also with the acceleration factor, you need to calculate. It will be V3 0 plus alpha into V3 updated minus V3 initial guess. Okay, so this value I'm directly writing the answer. So this is 0.9907 minus J 0.0469 per unit, or in polar form 0.9918 at an angle minus 2.71. Okay, so now one more bus is there, so you need to do in the same kind of way to find the updated voltage for bus 4. Now K equal to 4, V4 updated is 1 by Y44 into P4 minus JQ4 by V4 0 conjugate minus sigma I is equal to 1 but is not equal to K, that is 4, to N. N is also 4. Okay, YKI, that means 4I VI updated. Okay, so by this time you will be knowing how to do the expansion, but still for your convenience I am writing 1 by Y44 minus P4 plus JQ4 by V4 0 conjugate minus Y41 V1 updated plus Y42 V2 got updated already. Next Y43 V3 updated. Okay, so 4 can't be, I can't be 4. Okay, so don't write anything. So you'll be having this value, and also we were given with the acceleration factor. we will be having that formula as well. Okay, so V4 accelerated voltage, that is V4 0 plus alpha into V4 updated minus V4 initial guess. Finally, I'm writing the value. Okay, so whose value is 0.782 minus J 0.1093 per unit. In polar form, 0.9843 at an angle minus 6.38. Okay. In this way, we can do the calculations. And if you want to write all the values, at one place also, you can write as a result. Okay. Okay. So result, how you need to write? So the bus voltages at the end of first iteration are. So just write all the values in both rectangular and polar forms. So like that, whatever the voltage that you got, no? So those values you're supposed to write here. In this way, you can complete the Gauss Seidal method calculation for first iteration. Okay, so I hope you understand. If you find any doubts, please do comment. I will be answering. Thank you so much for watching this video.